All right, I'd like to begin this session. It is Underground Facilities Infrastructure, Topical Group 5, Synergies in Research at Underground Facilities. This session is focused on science research that is being done, science or engineering research done in underground facilities that is not directly related to high energy physics. It covers a number of different areas and different communities. And I'd like to thank the community contributors listed at the bottom of this slide who contributed a report to the UF5 report section of the SNOMAS report. I see that we have one person online as well as our captioner. We have 7 of us in the room here. I invited folks from the community to participate if they wished. I do not imagine all of them are present at the SNOMAS meeting. So this session is really just to ensure that there is an opportunity for people to see what is present in the UF5 topical report and for us to have any discussion related to that. I have slides. There's also a report online available. I'll go through the slides and then I will briefly show the report and then we'll have a brief discussion. Okay, so let me actually, can I get to the, how do I do the present? Just I'll use on screen. Okay, so the goals of the UF5, the synergies in research at underground facilities. We want to identify the breadth and nature of scientific and engineering research conducted at underground research facilities. So this is everything that's done in underground research facilities, not just high energy physics. We want to place in context needs and requirements for these research efforts. So this is understanding if underground facilities are used broadly by many different research communities, where do they have needs that overlap or potentially conflict? So yeah, we want to identify synergies and or conflicts and present those. And then we want to integrate that awareness into the breadth of underground science into our strategic plan. So we want to make sure that we're not doing things where, you know, the acts of one research community are negatively impacting or not taking advantage of activities in another research community. So that is the primary purpose of the UF5 synergistic topical group. The outline of the report, so this is the written UF5 topical report that I'm referring to. There's an introduction, and then currently there are 5 scientific engineering subtopics that are covered as part of this. Ideally, there would be some additional contributions from other research communities that I've listed here at the bottom of this slide: geothermal science, biology, geobiology, and interferometry. The rest of this presentation is a short synopsis of what is in the contents for the 5 that I have listed here. I will go through each of these and then we can discuss. All right, so the first is a introduction. This is the entire introduction to this portion of the report. It is fairly short. It is basically saying the same things I just said as the goals of this section here. I don't expect you to read this. You can right now, you can find this in the posted report, which I will show you how to get to after I go through this presentation. Okay, so now I'm going to go through, there'll be 2 slides for each of the different research, engineering, science sections. First here, accelerator-based nuclear astrophysics. Again, this follows the outline for the entire report. Each of the sections is broken down into science goals, method and facilities. There's a status, effectively what's going on and what the future is, and then an outlook for that research area. And so I've tried to capture, again, my synopsis of what I have seen written down by our contributors from the different scientific, engineering, and research communities. So for accelerator-based nuclear astrophysics, their science goal is to understand the synthesis of the elements in the stellar environment. Their primary methods: controlled nuclear reactions through accelerator-based reactions in underground facilities. Current status: there are 3 such facilities, infrastructure instrumentation at underground facilities around the world. Casper, SURF, LUNET, LNGS, and JUNA is, I believe, planned at CJPL. These are the 3 facilities that lead the field, and the report contains some detailed information on the usage and needs, which I did not have time or space to put into this PowerPoint presentation for today. I encourage you to go and look at their specific needs and usages in the report. And that can be basically set for all of the areas that we will cover. The outlook for accelerator-based nuclear astrophysics in underground facilities: promising science upgrades to the research facilities that I just mentioned above are being planned and will take their research into the future. So in each of these, I have requested from the community a picture representative of the underground facilities, the work that's being done in underground facilities for each of these. They provided a picture, which I'm very grateful for. I probably cannot speak to the details of any of these pictures, but I wanted people to have a sense of the infrastructure scale and the type of equipment that is being used for each of these different fields. Experiments in fundamental symmetries. Here, the science goals: investigate space-time related symmetries and wave function collapse. The methods and facilities used for this: precision measurements of X-rays, gamma rays in atomic and nuclear transitions. The status: there's dedicated experiments such as the violation of the Pauli principle. And there's complementary measurements which are made by other larger experiments. For example, Dama Libra, Borexino can make comments on symmetries from their experimental data, even if they're focused on larger things like, not larger things, but other things like dark matter or neutrinos. The outlook: precision experiments will progressively test fundamental symmetries and are quite often very synergistic with other underground research, underground measurement infrastructure. For example, if you're building high precision X-ray and gamma ray measurement techniques, those are very conducive to a lot of other things that are done in terms of measuring X-rays and gamma rays in underground facilities. So here's just a picture of the BIP2 experiment. Gravitational wave detection. Here, the science goals are to expand the range and distance of searches for gravitational wave events. The methods and facilities. Here, specifically to escape noisy environments, to get away from seismic, atmospheric, and electromagnetic phenomenon by going underground to enhance low frequency detection of gravitational waves. For status, Kagra in Japan is likely the only underground gravitational wave detector for the coming decade. The reason why this is the status is because, again, we're thinking about how other research communities are using underground facilities and how they may interact with our thinking about planning for future underground facilities. So identifying that there is one and then it's likely the only one for the next decade is key for our understanding of what the plans are. The outlook: the Einstein telescope is a future concept with 10-kilometer interferometer arm lengths. This would be a major underground facility, and evaluation of infrastructure for noise in underground facilities such as SURF, LNGS, et cetera, is key to understanding what the requirements will be for such a major underground gravitational wave detector. And so here's a picture of gravitational wave detection in underground facilities. Geology and geophysics. Here are the science goals: physics-based understanding of controls of permeability, stress, temperature, and chemical and biological processes across time and length scales. Again, this is for geology and geophysics. Their methods and facilities: controlled borehole drilling and subsequent instrumentation for within the geologic host. Again, they're very interested in the specific rock or other formations that they're drilling into to understand the processes that were described under the science goal. There is effectively a long-range plan, just kind of description of this research available through this report, a global survey of underground facilities. This report is very specific to the geology and geophysics community. It is not the same underground facilities as we think of them in the snowmass process. They are really talking about like putting holes in various different geological formations for understanding processes. So there may not be people underground, but there is a deep hole that goes underground so that they can study their processes. And there is an extensive list within this report that details all the work that they're doing at various facilities around the world. The outlook, both respectively, DOE and NSF are actively supporting and developing research in geothermal energy and carbon sequestration at SURF. And so this community is being supported by the US research agencies. Here's an example of borehole drilling and testing at SURF. All right, quantum information science. The previous session in the same room was on quantum information science. We discussed it at more length. Here, the science goals are to improve understanding and performance of superconducting devices for quantum sensing and computing in the face of environment-induced quasi-particles. Methods and facilities here: deploy low radioactive techniques for neutrino and dark matter science towards superconducting quantum devices in radiation shielded underground laboratories. Currently, there are numerous institutions that are installing QIS-oriented dilution refrigerators in underground facilities. The outlook at this time: tantalizing opportunities to improve quantum computing in underground facilities. This is something that we discussed at more length in the previous UF's cross-frontier session with instrumentation frontier in the previous 2-hour block today. And here is just some pictures of the various parts of what people think about when they think about quantum information science and underground facilities, superconducting qubits, understanding coherence time, and then building test platforms for this type of work. So in summary, right now we're at the point where we're trying to wrap up the report for UF5 synergies in research at underground facilities. The topical report, I will show that report in just a few minutes. The key thing for this session is to identify if there are things that are missing that will impact underground facilities or that are needed in the snowmass report to capture what's going on. My assessment is that there are no outright conflicts in research programs that are identified with these other areas of research or engineering. Or where there might be, there are appropriately tailored facilities that are available and in use. For example, the geophysics and geology, they have a broad program that I referenced in one of their planning documents. In several cases, smaller research programs benefit from the economy of scale associated with large particle physics programs. The point I think to make here is that when we build large underground facilities, it provides an opportunity for other research programs to become active in those spaces. And this really suggests a holistic assessment of the total science impact from underground facilities, not stovepiping it into evaluation just based upon a single scientific group or engineering activity. So with that, I will stop sharing the slides and direct people to the draft UF5 report, which can be reached from the Snowmass Wiki. So if one goes to the Snowmass Wiki and finds the underground facilities frontier area here, scrolls down to our topical groups listing, the draft UF5 report is put here. And that report is shown here. and is just organized in the same non-ordered fashion as I went through the different research areas on the slides with the contributors that's there at top. I've noted where it would be good to get additional contributions from other research communities. Again, there's the introduction that I showed at the beginning. And so the discussion that we had in the previous session related to quantum information science has suggested that we move up the QIS section, which is at the very tail end of this report, to highlight it as an area of more overlap with the high energy physics community. And so we will probably be reorganizing this section to provide more emphasis on that overlap between QIS and high energy physics. At this point, I'd like to stop, take questions, hold discussion, really with a focus on finalizing this document. Please.
Hi. So first set of questions. My name is Sijbrand de Jong. I'm a little bit an outsider on this process. I'm from Europe, but I am the chair of the Scientific Advisory Committee of the Astroparticle Physics European Consortium, the body that organizes the strategy for the European astroparticle physics. Let me first of all, I would like to go into the gravitational waves. I was a little bit surprised by some of the remarks, like that Kagra for the next decade would be the only experiment. Is that really true? I know it's not true because certainly Virgo is going to run.
Oh yes,
and,
you're right.
and LIGO is also going to run. So it's not the only thing.
Okay, so I'm going to switch over to my laptop so I can take notes too. So please keep going and I'm going to get some notes.
Okay. And it is relevant in the sense that you were also talking about the Einstein telescope. Of course, there's also an initiative in the US, the Cosmic Explorer, which I didn't find a mention of. I didn't really sort of scrutinize the paper yet, but it's probably also important to mention. And one of the things that we're concerned about in Europe is how to concurrently set up the Einstein telescope and the Cosmic Explorer while running at the same time with the same community. Virgo, LIGO, and Kagra. There's not necessarily a competition for underground facilities there, but there's a competition for human resources. So I guess that's one set of comments which I sort of didn't find as such in the document yet, but I may have just not carefully read it. I don't know if anybody wants to comment on this.
Can you cover again for me your comments about the Einstein Explorer?
Sorry, it's the Einstein telescope and the Cosmic Explorer.
Cosmic
They're two
Explorer,
different
sorry.
apparatuses.
Sorry.
you preemptively already merged them, but I think that's not the intention. In fact, it's crucial to have several gravitational wave detectors active at the same time. In fact, only the Einstein telescope will be able by its own to actually have some pointing sensitivity. The others rely on the fact that you have more than one detector to have pointing sensitivity. So therefore, the running of Kagra, and therefore this was a strange comment that Kagra would be the only experiment in the next decade. The running of Kagra, LIGO, and Virgo are very closely coordinated, so that they do maintenance at the same time, they're up at the same time, because you need at least 2 out of 3 to do good science. So, so that was a little bit a strange comment that Kagra would be the only one. Of course, between us, okay, Kagra is the only one that's in trouble right now, but okay, that's a different story. So they still have a lot of development work to do. And then for the future, the plan for the Einstein telescope is, I think, pretty mature. The plan for Cosmic Explorer is certainly there. He's not yet that mature, but in any case, from the European stance, we would very much welcome the Cosmic Explorer also to materialize. So it's not a competition. The Cosmic Explorer would be a major asset to the Einstein telescope, and vice versa.
So Cosmic Explorer is an above ground facility. Einstein telescope is an underground facility.
Yes. It is not that deep underground, okay? A few hundred meters. So for example, so that was also why I was a little bit puzzled about the comments that, for example, in Gran Sasso, there would be measurements for noise related to Einstein telescope, because I think that's only very marginally relevant, because it's not going to be the same types of background that are of interest. For gravitational wave detectors, it's the Newtonian noise which is of interest, not such things as background radiation or yeah, things like that. I mean, their noise is the ventilation. And you're not going to study that at other underground facilities, because there, I mean, that it makes a bit of noise doesn't matter. So then in a completely different corner, much more particle physics. Am I going too fast, or?
No. I'm just trying to capture what's going through my head. Yeah.
So what about neutrinoless double beta decay? This is sort of up on top of the agenda. Where will Nexo and Legend 1000 be put?
So they actually fall into the
Neutrinos?
Neutrinos, yeah. Because although SNOMAS's intention basically focus on high energy physics, and so the question was about neutrinos double beta decay and where that lands in the SNOMAS process. For underground facilities frontier, for us that lands into underground facilities for neutrinos.
Okay.
Within underground facilities for neutrinos, there are effectively 3 subtopics. One is long baseline neutrinos, DUNE. The next is neutrinos double beta decay. And then the third is underground facilities for other natural neutrino sources, astrophysical neutrino sources. So neutrinos double beta decay is captured. It is one of the things that we actually have substantial writing on in our reports.
Okay, so if I then understand it correctly, sorry, I'm an outsider on this a little bit. And the energies and research is basically everything else that you can also do at underground facilities, except for topics that were already listed.
Pretty much, yes.
Okay, so it's not about synergies between underground facilities, for example.
Yeah, it's like the synergy of the underground facility, not necessarily of the research. Although if we see those things, we would like to identify them. The real thing is to make sure that we're not stomping on each other. I think that's the key thing, right? Identify that there are other users of these facilities and make sure that we're not stomping on each other. That's really the key goal.
Okay. So in which group is like the synergy between underground experiments falling, between underground facilities? Is
That would be
covered
us.
somewhere?
So the underground UF frontier would be the ones who would document that.
Okay. Well, okay. At the moment, we're really thinking about combining the efforts of the underground labs in Europe. Like what can be combined, what is in common. So things like material screening, So setting up a general material screening database, which could be important for basically any of these topics you want to do in underground facilities. Essays on materials, etc. And how to do the screening. And these are topics that are in common, and there's much synergy to be still attained, because now everybody is doing it by itself, and all the labs have different standards in some sense. So there's a lot to be gained, especially also with material that could be moved around. Okay, that is sort of in some place in a repository, could be used in another place, but then the question is this acceptable, etc. So and that could even be very interesting, say across the continents to have synergy.
So I think I don't know. Would you like to speak to that, Alvin?
Thank you. Alvin Kamara from UCLA here. So we had a meeting in mid-June, the low radioactivity technique meeting in South Dakota, where we discussed actually this issue that you brought, you know, the synergy between different content facility across the globe. And I think Snowmass, to that effect, has already started something like that, where they have a website that they have been developing where different facilities can make even demand, you know, to use their screening facility for material content and so forth. And it's discovered actually in the UF4 Snowmass topical group. And I will be talking about the UF4 topical group report on Friday. And we will have again a live discussion on Saturday. 2 hours discussion going through the report, and then after that time, you know, you can what we have already written. Yeah, and then John is even pulling the draft of what we have already written to that effect. So it's a very good issue that you brought, and we have been thinking about that, and there is already a structure into place to address exactly what you brought. Perhaps you want to add something, Jetta?
No, that was perfect. I just wanted to point out that a lot of those supporting capabilities are in UF4, and that's, I think, where they've been doing most of the thought about broader collaborations between laboratories on that specific piece. I think, well, personally, I think collaborating between Europe, the US, and Canada on the double beta decay program is another topical area, but that's frankly politically trickier at some level to write down how that works. Is that fair, unfair, John?
Okay, and for my
So I'd love to talk to you about how we could,
sure, maybe take it offline.
yeah, write about that.
So then direct dark matter detection would fall under UF02, I guess.
So thank you for your comments. So we do have this UF5 report, and it is for review and contributions from the community. So I encourage you to read it and get in touch with us, me, if you have comments. I don't have, I think my email is on here somewhere. John Orell, Pacific Northwest National Laboratory. There's my email. So if you would like to take a look at the UF5 report and provide feedback, just send it directly to me. This is exactly what this session was for. Other comments or questions or discussion points?
Just one that a thought came to me, and I don't know if this is useful, but discussing how having this broader science program enables multidisciplinary discussions between physicists and non-physicists, sort of breaking down that barrier a little bit, since they're co-located for some of that research. I don't know if we want to think about a point along those lines, in addition to just saying, here's a place where they can do their research.
I don't have anything like that in the report right now. We can definitely augment it. Basically, right now, there's just an introduction and then it just lists the contributions that I have from the community. So having a conclusion or an addition to the introduction will be fine. Jeter, you can obviously contribute to this. Yeah.
So in the draft report, draft report, you had a couple disciplines that you didn't have content for yet, and I was just curious. Like biology is a good example. Do you have folks lined up to give you words on that, or do you need? I'm not necessarily volunteering, but do you need help on specific areas? I guess is a general question.
Yes and yes.
I was afraid of that.
So we have reached out to specific people. People are busy, right? So some people have said yes and haven't contributed. Some people haven't responded, which means, yes, we need assistance and help. If we want to have those additional sections in this report, we'll need to find people to make contributions.
Then on that same topic, one other large swath of a discipline would be engineering, at least at SURF. That's one of our disciplines that we cater to. And here, even getting back to the discussions this morning on QIS and interest from industry on collaborating with underground labs, we have some partnerships with industry. Caterpillar is a great example. And so that would be another area that we might be able to contribute some words to. Just on general industry. And then a final comment, perhaps, on atom interferometry. That's where we've had some discussions at SURF, and our vision workshop highlighted that. Perhaps even a slightly more broad application, there would be a vertical facility. And what other science could be brought under that same umbrella. So atom interferometry these days is a great poster child for a compelling science that would take advantage of a vertical facility. I'm not sure if you've received much in the way of input from others that might fall into that.
So in this particular case, I do not have a contact. So if you have people who would be able to contribute, that would be fabulous.
And then I wanted to, in my last comment, look back on the Cosmic Explorer, the gravitational wave. I was curious on how real that is, and how much this snowmass and this community can nudge that. Where is it in its planning? Is it possible to send underground? Does the gravitational wave community decided on? So Einstein telescope in Europe is underground a little ways. Is the US equivalent have a benefit for going underground, or is it? I don't know. It should be mentioned in the report, and I was wondering if, even from your European perspective, if you have any illuminating words for the rest of us on that.
Or maybe we cannot speak with one voice, but at least with one microphone. Yeah, so let me start with saying that I think the Einstein telescope has actually become very real. So in fact, a little under €1 billion has been reserved in the Netherlands for construction. So that's pretty serious. That's on a total construction budget of somewhere between 2 and 3 billion. So this is like really a step. So we all think that this is going to be real. For the Cosmic Explorer, they're not that far yet. Of course, like I said, it's just very important. It's very important that in addition to the Einstein telescope, there's also the Cosmic Explorer. By the way, as well as LISA, but that's sort of deeply negatively underground. That's in the sky. I think all of these things are going to be like a few hundred meters underground. Yeah, of course, it's a little bit definition of an underground lab, but a lot of the a lot of the infrastructure shows similarities to the deep underground labs. It's of course it's not all the same in the sense of safety, etc. It's not because of radiation shielding. It's just because of Newtonian noise. So just like the ordinary noise that people produce on the surface of the Earth shielding. So typically you try to find like Kagra or the Einstein telescope, a good piece of rock that is sort of embedded in a much looser structure of ground, so that it moves as one piece. That's very hard to attain on the surface. So it's going to be underground, that's for sure. It needs not to be very much underground. Like if you find such a formation a few hundred meters down the surface, that's okay. Yeah, how real it is, I think it's much more in the conceptual stage than say the Einstein telescope. Is it important for Europe? Yes, it's very important for Europe to have this facility in the US as a counterpart. From the particle physics point of view, do we support it? In Europe, we actually support this from the particle physics point of view, because there's some overlap with particle physics, but mostly for two other reasons. It's complementary fundamental science. It's the fundamental science of space, the space that your particle physics fields live on. And it's also a large facility. So in terms of teaming up between large facilities, it's also important to onboard them. In Europe, I don't know for here, but in Europe we have like this league of large facilities. So there's just a club of facilities like CERN-sized things that meet and discuss common problems and approach, specifically also approach politics together.
Just in terms of influence of this process on the efforts in the US, the Cosmic Explorer, I did have a short discussion with Marcelli, the convener in Cosmic Frontier. So that was much earlier in the process, and it was uncertain how much they would emphasize gravitational wave observatories in this process, because it's typically largely in the astronomy community's decadal survey. So I would point you there for the full discussion of where that instrument is, and where the community is thinking they are in the process of that. Yes, but I think we would want to be aligned with how the Cosmic Frontiers is putting forward gravitational wave observatories. I think they are including it, so we would just want to align with that. And I do believe they are considering shallow depths, as he said, to reduce some of the vibrational noise. Gravitational noise.
Thank you. Just to piggyback on one of the first questions Jared had about, contribution to, for instance, I was thinking about timeline, because even for our UF4 topical report, we also had like some inquiry about contribution. So what is the timeline for this NOMAS process? Is it the final hard deadline for the report to be public and submitted? No more change?
Well, I will tell you what I'm being told, and they wanted us to have essentially 98% drafts this week, and we would just be ironing out, minor wording in the next week or two so that they would be done in August. I know that we're we are further behind than that, but I also think that we don't have as far to go to be done. So from my perspective, this discussion here is about looking at what we have here for the report and figuring out how to augment it to capture the community input. And then we need to finalize it. And we should do that in the next week or two.
Thank you.
Okay, so if there are no other comments or questions, we can close this session. Again, the path forward is for people to look at the reports and provide feedback. Essentially, I'm the point of contact for this, this portion of the UF reports. I should probably make that more clear in the actual document. I will do that and get it reposted with my contact information so the things, contributions and corrections can come to me. But that will be our path forward, is to collect any additional input in the coming couple of weeks and then finalize this report as part of the entire snowmass book. So with that, thank you for coming. Thank you for your attention and thank you for your contributions. And I look forward to hearing from those of you who want to influence this report. Thank you.